Hey guys, welcome back to my channel for another video. Today we'll be looking at infinity. What does it mean and how is the concept used in math? And did you know that there are some interesting facts about infinity? Let's get right into it.
Hey you, over there. I see you struggling with the numbers, but don't have no fear, cause I'm right here. We're gonna grow and learn together, there's no need to despair. Math cool like breeze, you're gonna learn it with ease, so leave your concerns because it's time to learn.
If something has no limit or end and just goes on and on and on forever, we describe it as infinite. This means that we cannot ever get to the end because the end does not exist, and that is how we measure infinity. The symbol used for infinity is, and it looks like the number 8 turned on its side. The whole concept of infinity was first recorded by ancient Greek mathematicians, but the symbol was first introduced by this English priest who was also a mathematician named John Wallis. Today, not only is the infinity symbol used in math, but also as a symbol of love. Now, the easiest example of things that go to infinity, apart from love of course, is numbers. That's right, numbers have no end, which means that if you try to imagine the highest possible number you can think of, there are even higher numbers that exist. Or if you try to count all numbers, you could never get to the end. Numbers go to infinity. It's actually quite difficult to prove whether there are other things out there that are endless, like time for example, but see if you can give it a try. Think about it. Is there anything that you can think of that would have no end? Use your imagination. The possibilities are endless. But no, seriously, this is why numbers are so useful, because we are absolutely sure that they go to infinity, so we can use them to tell us more about the whole concept of what it means to be infinite. And there are actually some pretty cool facts that we can discover. Here are a few of them. The first one is that some infinities are bigger than others. Now, I think that this is such an interesting point because even though it sounds crazy, it's actually quite true. Let's look at some sets of numbers to explain how we know this. The set of whole numbers start at 0 and goes on forever, so it's an infinite set, right? Now, in chapter 3 of volume 1, I explained that decimals are numbers found in between whole numbers, and there are an infinite amount of decimals that we can find in between every whole number on the number line. So think of this. If whole numbers are infinite, but for every pair of whole numbers there is an infinite amount of decimals in between them, it means that the set of decimals is a way bigger infinite set than the set of whole numbers. Basically, it means that even though we could never count all the whole numbers that exist, and we could never count all the decimals that exist, we still know that one group is bigger than the other, and hence the concept that some infinities are bigger than others. Now, the second concept is that some infinities have limits. This is actually a more advanced topic in math, so I won't get into it too much. Let's take our previous example. If we were to look at all the decimals between 7 and 8, for example, we would get closer and closer to 8 without ever actually getting to 8. So even though the decimals in between these two numbers go on forever, it never actually passes 8, and we say that the limit is 8. Think that's cool? Here's another example. Imagine a piece of paper that we keep separating into different pieces. 2 pieces, 10 pieces, hundreds, thousands, millions of pieces. As the number of pieces get bigger and bigger, the smaller each piece becomes. Even so small that you probably cannot see it with your eye. But guess what? As close as it gets to nothing, it will never actually get to 0. So we say that the limit is 0. Now, the last thing we're going to look at is something called Xenos. I actually do not know how to say this name. Oh, yeah. So basically, this Greek philosopher called Zeno came up with these arguments that went against everything that was physically impossible, yet made perfect sense when it came to the concept of infinity. His whole argument was based on the fact that the space between two objects were made up of infinite amount of half spaces. So imagine if a ball was here and another ball was rolling towards it, then it would first have to roll half of the distance, then it would have to roll half of the first half distance, and then half of that distance. And from that point, there are so many half distances that the ball would have to cover, an infinite amount, that it should never be possible for the balls to ever touch. In fact, how is motion even possible? How is it that we get up to go to the fridge, or when your mommy sends you for the remote, it doesn't take us forever because we are literally covering an infinite amount of steps in like 5 to 10 seconds, and things touch all the time? Now, the first thing that I'd like to say is that Zeno probably had way too much time on his hands, because like, who comes up with this stuff? And even though some of his arguments were solved over the years, with the introduction of physics, there are still quite a few that to this day cannot be explained. Even when we consider things like time and speed, there is still no proof that some of these things that we do every single day should even be possible. This means that there is so much about infinity that we have yet to discover. It also means that by the laws of math, even walking across a room means that we are doing the impossible. Yeah, so you can think of that the next time you get up to go get something from the fridge. And that covers the end of this video on infinity. Remember to like this video if you enjoyed it, comment below if you learned something new, and finally, be a friend and tell a friend. Remember, we're all in this together because math is life.